Hi everyone, in this video we look at investigating horizontal and vertical transformations. So first off, we're told using the graph of the function f of x to the right, we want to evaluate f of 0, we want to evaluate f of 1, f of 2, and f of 4. So to do that, we can use the graph, we can look at the corresponding y value for each x value on the graph. So if I want to evaluate f of 0, I look at the value of the y value of the graph when x is equal to 0. So f of 0 is just equal to 3. If I wanted to evaluate f of 1, I would go to an x value of 1 and figure out what my corresponding y value is. F of 1 is equal to 4. I can do the same thing for f of 2. F of 2 is equal to, well, when x is equal to 2, y is equal to 0. So f of 2 is equal to 0. And f of 4, well, f of 4 is equal to 2. So f of 4 is equal to 2. Now let's look at another example. We're told to determine f of 0. So let's see, what does this mean? F of 0. Well, it means that first let's evaluate f of 0, and then we'll take that value and then we'll evaluate the function at that value, and then we'll take that value and then we'll evaluate this function at that value. So this is, here we've got what's called a composition of functions. So let's go ahead. First, we know that f of 0 is just 3. So this is equal to f of 3, because f of 0 is 3. So now I can actually evaluate, f of 3. F of 3, well, let's look at our graph. F of 3 is equal to 1. So f of 3 is equal to f of 1. And f of 1 is just equal to 4. So I can evaluate f of 1 to get 4. So you can see that you can use the graph of a function to evaluate the function at specific x values. Let's continue on. In this next example, we're told using the graph of f of x to the right, it wants us to determine f of negative 4 plus 2, f of negative 2 plus 2, f of 0 plus 2, and f of 2 plus 2. So, to evaluate f of negative 4 plus 2, let's look at the value of the y value of the graph when x is negative 4. So for x is equal to negative 4, let's see what we have. This is negative 1, negative 2, negative 3, negative 4. We have a y value of 1, 2, 3, 4. So f of negative 4 is 4. It's this point right here. I have 4 plus 2, which is equal to 6. F of negative 2 plus 2. Well, let's see. What's f of negative 2? F of negative 2 is 0. So this is equal to 0 plus 2, which is just equal to positive 2. F of 0 plus 2. Well, let's see here. F of 0 is 3. So this is equal to 3 plus 2, which is equal to 5. F of 2 plus 2, well, let's see here. F of 2 is, the x value 2 is right here, and f of 2 plus, f of 2 is going to be equal to 1. So f of 2 plus 2 is 1 plus 2, which is equal to 3. So to figure out, okay, for all these, to figure out the values of f of negative 4 plus 2, and f of negative 2 plus 2, and f of 0 plus 2, and f of 2 plus 2, I can take the y values from the graph, and I can just add 2 to all of them, okay? So it wants us to plot the graph of f of x plus 2. So let's think about this, and let's think about what we just did. What we just did when we evaluated each of these, each of the function, and then added 2 to each of these values. Well, I took the y value at each of the respective x values, and I just added 2 to them. So to plot, if we take f of x and we add 2, we're just adding 2 to each of the y values. So if I want to plot f of x plus 2, well, I can take each of the y values for each corresponding x value, and I can add 2 to them. So I can take this point and I can add 2 to that point, or to the y value of that coordinate. I can take this coordinate and I can add 2 to the y value of that coordinate. I can take this coordinate, I can add 2 to the y value of that coordinate. Same thing here, and same thing here. And now I can connect all these points and see what my graph looks like. Well, if you notice something, if you look at the graph, you might notice something. How are these two graphs related? Well, so that is, how is the graph of f of x, or f of y is equal to f of x plus 2, how is it related to the graph of f of x? And you might have already noticed this, but if we take the graph of f of x and we shift it up 2 units on our grid, we get the graph of f of x plus 2. So again, this is, whoops, what I've plotted here, I've got the graph of f of x plus 2. If I wanted to graph f of x minus 2, well, I could take all of the y values of f of x, and I could subtract 2 from them. So that would shift the graph downward 2 units if we evaluated f of x minus 2. So here it says, how is the graph of f of x plus k related to the graph of y is equal to f of x? Well, the graph of y is equal to f of x plus k is related. Let's say it is the graph of y is equal to f of x plus k is a vertical shift of f of x k units upward if k is positive, and k, let's say absolute value of k, units downward if k is negative. So if k is negative. What that means is that if k is negative, then we're shifting the graph downward. And you can see this if you computed if you did use the same exercise for f of x minus 2, then you would see that we'd produce a graph that would look like this. Like, let's plot f of x minus 2. Well, we could shift all these points down 2 units. And our graph would look like this. So this is the graph of f of x minus 2. And I should really write this as y is equal to f of x minus 2, and y is equal to f of x plus 2 here. So in the next video, we'll look at horizontal translations.